All right, hello everyone. Good evening. I hope you're having an excellent first Wednesday of April. So, kicking us off, if you're not familiar with me, I'm Tiffany, head of our events committee, setting up a for you tonight. Hello to all of you who might be hanging out at the E-Factory. I hope you are enjoying the pizza. Just a couple of notes before we get into our presentation tonight. The virtual study work group. You may be familiar with this event. It has been running on a weekly basis for a while now. They have moved to Thursday evenings. So they meet every Thursday evening at 6 p.m. You can find their information in our meetup. So I'll drop our meetup link in the chat here. I will remind everyone, if you are not part of our Discord, that is the place to get probably the most relevant information about what goes on in our group. But that virtual tech study work group is open to anyone and work, kind of an accountability group. So has now moved to Thursday, 6 p.m. That's a virtual group. They're using Zoom. So you can get all the details on the meetup. The Springfield Tech Council has announced that the Tech Awards are going to be coming back this year. They are targeting October as a date for when that award ceremony will be held, so keep an eye out for that. So pretty excited that those will be coming back. And then the 200 OK Web Development Conference is coming up Friday, May 20th. And we know that there's already some coordination about people that want to go and carpooling. So we know that there's at least one carload from Springfield that went there that morning and then coming back the same night. And this is something that we've usually done in the past, little caravans. And I'll drop the link to this event in the chat as well. But if you're interested in going to the 200 OK Web Development Conference in Tulsa and would like to get in on school, reach out in Discord. Mike also said he had some details and would throw some stuff out in Discord for those who are interested. So if that seems like something that you would like to know more about, just say hey the Discord so we know who all might want to be in on the carpooling. So again, if you're not part of our Discord, I would say that's the easiest way to get connected with everything that's going on in our group, discord.sgf.dev. Make sure you're plugging in with all of the stuff going on. Of course, we have the meetup, and you can we put all of the events on the meetup, so you can have all of the notifications about the events as they are posted. But I think that is all for the announcements that I had this evening. So if you do have questions while our presenter is speaking, you're more than welcome. If you're watching this on Twitch, you could post those in the Twitch chat, and I'll make sure that Chris sees those. If you're in the Discord, direct over to our chat that is entitled
All right. Hey, everybody. My name is Christopher Baunach. I am a front-end software engineer at Reach Platform, which built and maintains the Reach language. Today, I'm going to be kind of going through some crucial concepts covered in the first talk. So we're going to be going through what is essentially a simplified version of the tutorial. And yeah, let's get right into it. Actually, 1 second. It looks like there might be some audio issue. Oh well, we'll go ahead with it. So we're going to start with this itinerary of what we're going to be covering today. So we're going to begin with a kind of review of each, and this is just going to go through the basics of the language, not those kind of basics, but a kind of overview of the language, go through some diagrams that show how it differs from maybe what we're used to, and then delve that into a basic rock, paper, scissors program built with Reach. And then we're going to review that in depth to kind of do that review, and then we'll go forward with that into adding betting. This is raise the stakes of the program, and that's important because the thing right after that is going to be addressing the vulnerabilities prior to iterations of that application. And then we'll go into how to address that vulnerability, other vulnerabilities, address them, and then change the application slightly so that the two players of the rock, paper, scissors game keep on playing even if there is a draw. Last but not least, we are going to make this rock, paper, scissors program interactive. All prior iterations noted are kind of automated tests in a sense. And yeah, let's dive right into that. Oops. Okay, so what is Reach? Reach is a language for building decentralized applications. A decentralized application, or DApp, is one that runs on a decentralized computing system or chain. Ethereum is one example of a decentralized computing system and is built up of a network of around 3,000 plus nodes around the world that work in concert to compute the logic of these dApps. In addition to Ethereum, there are other chains like Algorand, Conflux, etc. Reach is primarily an immutable functional language. There are some elements of mutability, and we will actually be covering one of those in this talk today. I like to say it uses a gradient of the JavaScript syntax. So starting out, a lot of what you write will look like JavaScript, whether that be creating functions, defining constants, or chaining functions, etc. But as you get into the more Reach-specific operations, it'll start to take on kind of a syntax of its own. Reach will probably be very different starting out than what you are used to. Whether you are a front-end engineer or even full-stack engineer, coding with Reach is probably going to be quite a change of pace from what you code on a day-to-day basis. Nonetheless, after a while, you'll get used to the new structures and patterns that you need to use to code with Reach. So here is kind of a broad overview of how computation flows in Reach. Some of us might be familiar with other forms of computation flow like object-oriented and kind of class-based systems. But in the case of Reach, it's more a directed graph starting from a central point, in this case, app init, and then going into that directed graph of steps. However, in addition to a directed graph, each of those steps then breaks down into a sequence of Reach functions into three specific categories: steps and local steps, which are then followed by consensus transfers, which are then followed by consensus and local steps. So this is a more in-depth way of looking at that. This includes some of those Reach functions and the categories in which they fit in, like assume as a local step, or wait as a step, or participant as falling under the app init, and kind of the flow that these functions go through. And this is taken from the docs, and I will have a link to the docs in addition to the slide deck posted the blockchain channel a bit after the talk. I like to kind of unify that diagrams with the code so that we could kind of see, okay, here's the concept, but here is the concept applied. So over here on the left of that directed graph going from app init into these steps, and then we have on the right a basic Reach. We could see kind of how it has that JavaScript syntax and the various categories of the sequences that fit in. And so we have the app init, then going where .only is used, we have the step, then the interact.request is in the local step, Then we have the consensus transfer with a publish, and finishing off that step, overarching step. It's kind of with the recurring uses of the step word, I'll admit that. And finishing up with the commit consensus step. So let's kind of see all that applied in a rock, paper, scissors program. So we're going to start with the front end portion of this rock, paper, scissors program, which is this somewhat simple file that's going to start with loading the standard library. You'll notice there isn't a package.json. This kind of is brought in through downloading the Reach library, which will also be in the Reach docs. And then say you were using this in maybe a front end setting. In that case, you would call the Reach standard library from npm. Then we are going to import in this backend file, which is the compiled index.rsh file. Whenever you compile it, it will create this build folder with the file. Then finishing up the import process of the standard library. And then we're going to go into building out the accounts for 2 players of this game, Alice and Bob. And then after we have their accounts generated using the standard library, we're going into having Alice deploy the contract, importing that compiled contract in the form of the backend, and then having Bob get in the case of GetInfo, getting contract address so that he could join that contract or that game of rock, paper, scissors. Then we're going to have the comments for the game, and then this large thing right here is going to kind of be an interface that specifies the functionality of these players. So a get hand function, which is going to get a hand and return that to the contract, and a see outcome function, which is going to get the outcome from the contract and display that to the front end. Then we're going to have this wait over here, which is going to take those contract objects of the user accounts, give them the interface, and then run them. So that is the front end portion of that rock, paper, scissors. And I probably should have mentioned this earlier. We are going to kind of be doing overviews of these applications instead of reviewing them, just to kind of draw the crucial concepts from these overviews. So going over to the contract portion, we can immediately see some parallels. We have the player interface on the front end, and then we have its corresponding interface on the contract side. And we have these specified contract objects over here on the front end, and we have their participants being given the interface on the back end. So that's going to get us through that app init step that we saw earlier and move us down into this here, which is going to be Alice calling the get hand function from the front end, getting the data that passes back, and because it is private by default, declassifying it and then publishing it to make it public to the contract, and then committing that. And then we're going to have Bob doing essentially the same process before as Alice did. And then now that both hand Alice and hand Bob, the representation of paper and scissors, are present and usable, we can now calculate their outcome. We'll calculate who, essentially. And then this each function, this is going to be the first time we've seen that. That is essentially to prevent us from having to do 2 onlys, just to call the same interface function for both users. So we're just going to get the users that share that function, put a list of them into the each, and then we could call that shared function. So let's see this in action. So we're going to call this is going to stand up a devnet. In the case of my setup, I have it defaulting to using the Elgran chain. So we could see Alice playing rock, Bob playing paper, and Bob wins. Okay, well and good. Basic. rock, paper, scissors game with Reach. Let's go to the next stage and add in betting. Okay, so a bit changes here in starting out. Have these two new functions, format and get balance. This is going to format the currency that comes from the backend. It comes from the backend in a big number, and then also this get balance, which is going to kind of display the balance of the user's wallet. Then we're to have these before constants, and these are going to tell us what the user's wallet started out as. Then down here we are going to have them afterwards. But here in the middle is something pretty crucial. In addition to the interfaces that they had in the last iteration of this, they are also going to have some new functionalities. In this case, Alice is going to pass in a wager. I guess we could call this $5. And then Bob is going to have this new function where he accepts the wager and the contract lets the front end know how much that wager was. And then just printing out of how much they bet, who won, who lost. Okay, so over to the contract side of that, we're going to have, again, the kind of corresponding wager and accept wager. Alice getting that wager value from the front end, declassifying it to make it public, publishing it to make it to the other portions of the contract, and paying that $5 into the contract. Bob is going to call his accept wager function and also pay his wager into the contract. And then the logic of calculating the winner is a little bit more complex now that we have to distribute the wagers based on who won. See this in action. And again, that's going to stand up local network on. You can see Alice playing rock, Bob accepting the wager of 5, Bob playing rock, and the game and a draw. Now, the reason these didn't go from 100 to 100 is much in the same way that if you send a letter, you pay for a stamp to put on that letter. In chains, you need to pay for transactions that you make on the chain. So Alice's transactions cost 0.004 and cost 0.005. So there is actually a glaring vulnerability in this contract, and we are going to show that with the running of the next example. And then after that, we will go ahead and fix it. And before it even runs the program, it's going through and it's compiling this code. It's finding a verification failure. And in this case, that verification failure is Bob knows Alice's hand before he even plays his hand, because Alice was publishing that hand, making it public to the rest of the contract. So now whenever he plays a game using this contract, he could just go out to a chain explorer, get the transaction where Alice submitted her hand, and say, oh, she played paper? Okay, I'm going to play scissors. Or she played rock, I'm going to play paper. And so this essentially destroys the whole purpose of the game, and that it's unfair at the point where Bob could win every single time. So how are we going to fix that? We are going to explore that in this next contract. So starting out, before we get into the actual fixing of how Alice just shows her hand privately, we are going to do some extra verification. And to do that, we're kind of going to make some enums up here. We're going to create this logic, which is how we were calculating the winner before, run a few manual asserts that kind of verify of the rock, paper, scissors game. Rock loses to paper, paper wins over rock, and rock can result in a draw. But in addition to that, we are going to run these 4 alls. These 4 alls are going to verify the entire range of this unsigned integer, and in some cases it could be a 256-bit integer. And this kind of shows the power of the verification engine that Reach is using under the hood, and that instead of it taking hours or half an hour to run the whole integer, it takes just a matter of seconds. And this is due to how under the hood the verification kind of condenses these verifications. And we're also going to do that for all draws to verify that all draws are functioning correctly. And then after that, we could kind of get into how we're going to resolve this attack. Starting out, we're going to add this new hasRandom operation to the interface, and this is built into Reach, and it's going to correspond with on the front end coming from the standard library, which essentially gives the contract the ability to get a random number on the front end. Since, as we just saw, the chain being public, it can't really generate its own random numbers. And then going into Alice's first step, she's going to get her hand as before, but she's not going to classify it, and she's not going to publish it. Instead, she's going to run its make commitment, which is going to use that hasRandom function to generate a salt, push that hand through that salt, generating and also returning the salt, and then Alice is able to declassify that commit and publish that instead. This allows us to run this unknowable, which verifies that Bob does not know what his hand is, and he does not know what the salt that Alice has generated is. And so now that Alice's hand is obfuscated, Bob is not able to spy on it, and so he has to honestly submit a hand. Now, this does introduce an attack vector for Alice, though, in that she could, now that Bob has published his hand, go out, check what it is, change what she plays. So he played rock, so now she's going to play paper. And that's where this check commitment comes in that now Alice is going to publish the salt and the hand, and then those are going to be in the check commitment to verify that the commit that was published earlier lines up with the in the hand that Alice just published. And then it's just going to go through the rewarding process as before. Great. We have made it impossible for Bob to cheat and also made it impossible for Alice to cheat. Game is now fair. Kind of. There's still a vulnerability. It's not the same as this, but it can kind of essentially ruin the game, and that is non-participation. And so this is essentially Bob seeing that he can't win and just rage quitting. So and we're going to introduce this new informed timeout into the interface, and this is just going to let the users know if someone rage quit, if someone went away, and to kind of specify that timeout is also going to hand in a value when starting up the contract, and that's going to be the deadline for the timeout. Now, contracts measure time in blocks instead of seconds, so depending on the chain that you're using, you're kind of going to need to see how those blocks correlate with regular time and stuff. And Reach does offer ways to deal in regular time. We're just not covering that in this tutorial. So over here on the contract side, specifying that informed timeout function, specifying that deadline, and then kind of going through the same process as before, except when Bob goes to his hand, if he just doesn't want to play anymore, gets up and walks away, Alice is not left thinking I paid a wager into that contract and now it's stuck there. She specified a timeout, and that timeout is going to be so that if Bob doesn't respond in time, this close to operation is going to run. We'll close the balance of the contract to Alice, thereby returning her wager, and also call this inform time to let both users know the contract has stopped. Well, one of the users did not participate in the contract. But then on the flip side of that, we also need to do that for Alice to make sure that she does publish her hand and not see that she's going to lose and just walk away and spite Bob. And that would be terrible. So in the event that she does do that, it closes to Bob and Bob gets his wager and Alice's wager, and both users are notified that there was a timeout or there was a case of non-participation. I know I used rate, but it could just be someone left their computer for a minute, got distracted, and this allows kind of the contract to maintain a sense of fairness and a sense of if you kind of turn order and turn timeouts. Okay, so we've removed the first vulnerability, which was not denoting private data. Now we remove the second vulnerability, which was removing the risk of non-participation. We could kind of move into other concepts, which this next concept is going to be, instead of before when the game would end with a draw, now it's just going to keep on going. But before we do that, let's actually see this contract here run in action. And this might take a few, nope, just took one time. So we could kind of see Bob taking his sweet time to reply. He eventually does play a card. However, because it's a timeout, the balance that Alice paid into the contract is going back to Alice. So now we could kind of move on to eliminating draws from this. And we are going to do that by integrating a while loop into the contract. While loops function it differently in Reach, and these are where that mutability I mentioned earlier comes in that this will be the first time when a var used. In this case, it's an outcome which defaults to draw, and this is just to ensure that while the outcome is draw, it's going to keep on looping. In addition to that, a while loop in Reach includes this invariant and needs to include it. And this is just to ensure that the data that change stays stable throughout. So in this case, it's verifying that the balance of the contract is always 2 times after every iteration. So kind of going into some of the changes that were made. Now from the outset, just going to set the wager and deadline and pay the wager. She's not going to get her hand happen inside the while loop. Same with Bob, just going to get his wager, pay it. And then once we get into the while loop, the logic from before of Alice publishing her obfuscated hand, Bob publishing his, and then Alice revealing what her obfuscated hand was. And then the outcome will be calculated to determine the winner, and depending on that of a loop, or it will go down here, assert again that there is no possibility of a draw, and then transfer the balances to the corresponding winner. Okay, that's great. This is still, as we've seen, just a automated kind of test. Alice and Bob aren't actually playing a game of rock, paper, scissors. They're just automated code. So let's introduce interactivity into this contract, and we're going to do that in this next segment. It's just going to be a rewrite of the front end. s, this whole index.rsh is the same as the one over here. So it's pretty much just going to be redone from scratch. This is going to mostly stay the same, but we are going to bring in this ask object from the standard library, and this is going to give us access to a few basic kind of questions, so yes, no questions, and just general input from the users. So we are going to kind of see whether it's Alice or Bob who did this, well, who is starting up. And with that information, we could then publish who it is, and then go into creating their. Down here, it does specify DevNet with, in the case of Algorand and many other chains, you have DevNets, which are local to your machine, and then you'll have things like testnet, which are public, so you'll have to go out, account for them, get those funded, and then you could use them. Whereas if you're on DevNet, local to your machine, you could create fake test currency. So we'll just be using DevNets for now, net accounts. Then going into this next stage, depending on if it's Alice or Bob, it will create the contract or to the contract. And let's actually go and stop here and see that in action. Okay, we will need two CLIs, one for. And this CLI will be Alice, and she will create an account. We are currently on DevNet. And then this other CLI will be Bob. He will also create an account. And back here on Alice, she'll specify a wager of $5. The contract ID, the get info function that we saw earlier, will spit out this number as a bit, which we're going to carry over to that other contract or other CLI, and that is going to know which contract to connect to. Okay, going back to the code real quick. After that, to have those format and get balance functions from earlier, getting the user's balance at the outset so we could get it at the after they played the game. And then we're going to programmatically build that interface we saw earlier based on whether this is Alice or this is Bob. So we're going to start with that has random operation, which is going to ensure kind of trustworthiness through obfuscation. And then we're going to add to it the informing of the timeout based on whether it's Alice or Bob. We're going to add a wager and a deadline, or in the case of Bob, add an accept wager function. Then we'll have some constants down here, and these will kind of help to translate on what the user submits, whether it's rock, R, lowercase r, kind of into understandable hands. Then for both interacts, whether it's Alice or Bob, we'll have that get hand operation, and then finishing out with the outcome and the seeing of the outcome. And then in place of the promise.all, we will just have one await and kind of have that contract at the now complete interact interface. Then we'll get their balance after the whole game and call it a day. So kind of opening up those CLIs again, we will see Bob accept that wager. And then we'll see Alice play rock, Bob scissors. And we could see that Alice won and Bob lost his wager. Here we could see that again, Alice won and she won the wager. So that's kind of very broad overview Reach tutorial. So once again, if you've taken it already, then this kind of serves as a review, and if you haven't, then this kind of serves as a simplified overview of what to expect from it. So let's do a little bit more of an in-depth review of the itinerary. So we started out with that conceptual review of Reach, kind of going the summary of the language, the various diagrams that showed how computation flowed, how the operations flow, and things of that matter, going into the basic rock, paper, scissors program and kind of stepping through how that was assembled and how it works, going into adding bedding, showcasing the abilities of those two prior iterations, addressing them by obfuscating and to ensure that Bob couldn't just cheat every game. And then going into other vulnerabilities, non-participation, and how we protect against that with timeouts, integrating a while loop so that the game never results in a draw, always as a winner, and then wrapping up with the making of the scissors to be interactive. So I guess in summary, the crucial concepts that we're kind of drawing these are: know whether your data is private or public, because depending on that, you're going to deal in vastly different ways. Also, very much be aware of cases where there could be non-participation. Granted, you will have the verification engine backing you up on that, because it is on the lookout for any possibilities where funds are getting locked into the contract. So if there is a case where non-participation could ruin it, may very well kind of yell at you and say, hey, this could happen. Oh, shoot. I just now sent a message about making the font bigger. My apologies for that, everybody. And kind of at the end where we make it interactive, we could kind of see almost closely, because these aspects have been automated, how we would create automated tests for our contracts. Yes, the verification engine is running our contracts through a variety of tests, but as we make more complex contracts, we are going to want tests that verify the functionality of it. All right. I think that wraps it up. Again, I'm sorry I didn't see that message earlier about making the font bigger. I really should have caught that. And yeah, if you guys have questions, if you want to post them now or later, I'll answer them at either time, and I'll just hang tight for 5 minutes. You do. Or 3 minutes. All right. Well, again, if you do questions later on, feel free to throw them into the Discord and I'll answer them. Just a heads up for the third part of the work has kind of been getting crazy busy for me, so I will be doing that as a video and not a presentation, and just like posting the channel on the Discord. And I think that wraps up the talk for me. Thanks everybody. It's been great. And yeah.